Infrasound. Infrasound is a sound that we cannot hear. Infrasonic waves are produced naturally by earthquakes, volcanic eruptions, storms, lightning, and meteors, as well as by man-made sources like industrial machinery, wind turbines, and nuclear weapons. Elephants and whales use infrasound to communicate over long distances, and some migratory birds use it as a way to navigate, flying away from the source of infrasound to avoid storms along their route. It is unclear to scientists if these animals are able to hear infrasound, or if they are simply able to perceive it in more sophisticated ways than humans can. If we can't hear infrasound, then what exactly makes it a sound? And if it is a sound, then why can't we hear it? Before we start talking about sounds we can't hear, let's first talk about how sound works and how we hear what we do. Sound moves in waves, but unlike electromagnetic waves, sound originates from a vibrational source rather than an energy source. Things have to move to create sound waves. Sound at its base is created by the vibration of objects around us. For example, when you knock on a door, the movement of the door in response to your knock creates movement in the air around the door, causing a wave of pressure that transmits energy through the air by compressing and expanding the particles in the air as the wave travels through them. Each particle of air bumps into its neighbor, moving back and forth, passing along the energy from your initial knock and causing a chain reaction that carries the energy from the vibrating door to your ear. When the wave of pressure reaches your ear, it causes your eardrum to vibrate in sync with the compressions of the wave. Those vibrations are transformed into electrical signals by the cochlea in your inner ear and interpreted by your brain as sound, specifically a knock. So yes, infrasound is a sound. It behaves physically like any other sound, namely as a mechanical wave that travels through a medium, causing particles in that medium to vibrate as it moves. The fact that we can't perceive it doesn't disqualify it as a sound. Maybe some of the confusion stems from the way we talk about sound. As a concept, sound functions with a dual meaning. When we refer to something as sound, we can mean a physical phenomenon or the sensation that phenomenon creates with regards to our perception. Linguistically, sound refers to both the wave and the effect that the wave creates when interacting with our ears. Our experience of infrasound encompasses only the physical part. The waves are present, but the experience is absent. This raises the question, is sound only what we hear, or is it something broader, existing whether or not we can perceive it? So why is it that we can't hear infrasound? Because it just doesn't vibrate fast enough to resonate our eardrums. Infrasound is any sound below 20 hertz. Sound waves are measured in frequencies, which refers to the number of vibrations the wave creates each second, and the term that we use to express that is hertz. An infrasonic wave is a sound wave that vibrates 20 times per second or less. This is very slow for a sound wave, and it is the reason that we cannot hear infrasound. The length of a sound wave is equal to the speed of sound divided by its frequency. So the slower the frequency of a wave, the longer its wavelength. Infrasound waves are long. A 16 hertz wave, or a wave that vibrates 16 times per second, is about 70 feet long. For comparison, middle C on a piano is around 260 hertz, with a wavelength of around 3.2 feet. Infrasound's long wavelengths spread its energy over large areas, so the vibrations it creates in the air around us are too dispersed for our ears to detect. We may not be able to hear infrasound, but the effects its presence has upon humans and animals has been noted for thousands of years. The existence of infrasound was perceived long before it could be proven. The Roman lawyer Pliny the Younger witnessed the explosion of Mount Vesuvius when he was a teenager. In a letter written to the historian Tacitus in 59 BCE, some 20 years after the fact, Pliny described the charged anticipation of the atmosphere leading up to the eruption an unsettling sense of oppressive stillness, as if a great pressure had descended from the mountain long before the sound of the explosion from the volcanic eruption was heard or felt. The days before an 1805 earthquake near Naples are recounted in a letter to the editor published in The Spectator, a weekly British news magazine, in 1828. The letter does quite the job of describing unease in both the human and animal population. Here is a section of it. The oxen and the cows began to bellow. The sheep and goats bleated. The dogs howled terrible. The geese were alarmed and made much noise. The horses which were fastened in their stalls were greatly agitated. Those which were proceeding on the roads suddenly stopped and snorted in a very strange way. The cats were frightened and tried to conceal themselves, their hair bristling wildly. Rabbits and moles were seen to leave their holes. Birds rose as if scared from the trees, and fish left the bottom of the seas and approached the shores where great numbers of them were caught. Even ants and reptiles abandoned their subterranean holes in great disorder. All of this occurred many hours before the first shocks were felt. Large flights of locusts were seen creeping through the streets of Naples towards the sea the night before. What is it before the sound or shock of an earthquake is felt that warns both animals and people of the approach of some dreadful catastrophe threatening the very basis of their existence? No one, of course, can say, since the impression made upon the nervous system, at least as regards our own species, is evidently one of general disturbance, and not one to which experience attaches any explicit significance. It was not until 1883 that the phenomena of infrasound was documented in any way other than by anecdote. A large volcano in the Krakatoa archipelago in Indonesia erupted. The sound of the eruption was heard almost 2,000 miles away in Perth, Australia. The energy released from the explosion has been estimated as roughly 4 times greater than the most powerful thermonuclear weapon ever detonated. The eruption of Krakatoa triggered earthquakes and tsunamis and created a worldwide volcanic winter, dropping temperatures by almost a degree. For several years, the ash still present in the atmosphere from the eruption caused the sunsets to be a fiery red and the moon to appear blue or green. The jet stream, a narrow band of wind in the upper atmosphere that affects global weather, was first identified by skywatchers noticing a distinctive pattern in the ash as it made its way around the globe. A less spectacular, but no less important effect of the eruption was noticed in the offices of meteorologists all over the world. When Krakatoa exploded, the audible sound it created was heard thousands of miles away, but the inaudible sound it created traveled around the globe multiple times. Identical patterns of air pressure were picked up by barographs as far apart as Washington, D.C. and St. Petersburg. A barograph is a barometer that measures changes in air pressure over time. In the days following the Krakatoa eruption, barographs around the world registered an identical and repeating pattern of air pressure, the same pattern repeating at the same interval 7 times over 5 days, regardless of the location at which it was observed. Though it wasn't understood at the time, these fluctuations in air pressure recorded worldwide in the aftermath of the Krakatoa explosion are the first documented evidence of the existence of infrasound. The phenomenon that traveled around the world, disrupting local barometric readings, was a giant sound wave resulting from the vibrations of air at the site of the volcanic eruption. The term infrasound wasn't coined until 1930, when British scientist Albert Beaumont Wood began studying how low-frequency sound traveled underwater. His work led to the formal definition of infrasound as a sound below 20 hertz. During the Cold War, infrasound was used to detect nuclear detonations, and today, the Comprehensive Nuclear Test Ban Treaty Organization, the CTBTO, monitors infrasound detection arrays, consisting of microbarometers and hydrophones, in order to detect nuclear tests. If we can't hear infrasound, then what are we listening to right now? it's time to talk about sonification. Sonification is the process of converting data, in this case, infrasonic waves or atmospheric pressure changes, into audible sound. When you hear a sonification of infrasound, you aren't hearing the sound of the original event. You're hearing a transformed version of the data. Pressure changes caused by earthquakes or volcanic eruptions are translated into sound waves that we can perceive. Sonification allows us to experience what lies beyond our auditory limits. Sonification opens up a critical question about perception. If sound is both a physical wave and a perceptual experience, what do we make of sounds that we can't hear directly? Sonifying infrasound pushes us towards a non-cochlear understanding of sound, where listening is mediated by technology rather than our ears. The story of infrasound cannot be separated from the events that created. What we hear in these sonifications isn't the original event, the earthquake, the volcano, or the explosion, but rather a representation of it, a trace of the energy that event once moved through the air. Sonification is not just a technical process, it's philosophical. It makes us reconsider what it means to listen and challenges the primacy of our ears in defining sound. When we sonify infrasound, we are translating something outside our perceptual boundaries into a form we can understand. Yet we're not hearing the sound of the event itself, but the mediated data of that event. Another question: does sound as we conceive it exist independently of our ability to hear it? Infrasound waves have always existed, but it took sonification to bring them into our perceptual world. This shows us that listening is a constructed act, dependent not just on physiology, but on the tools we use to engage with the world. Another question: is a sound still a sound if it must be transformed for us to perceive it? Sonification is more than making the unheard audible. It reshapes how we understand sound as an experience. Our relationship to sound is always mediated, and what we hear as infrasound may be as much a product of interpretation and technology as it is of the events that created it. Sonification of infrasound doesn't just reveal it to us, it also challenges our framework for understanding sound in general. And I'll end with another question. Does sound exist independently of perception? Or is it real only when we can engage with it? If a sound does exist, but we Audio mastering by Sean McCann.